All right, so you got this information here on unit circle in your notes. Now, in Algebra 2, we do a lot of work with unit circle. Like we memorize a lot of values out of the unit circle that come up a lot, a bunch of things like that. We're not going to go into quite that depth, but you do need to understand a basic idea about unit circle, because so far, whenever you have seen sine and cosine come up, they've always just been these parts of a right triangle. But in a right triangle, this angle that we're going from here, it's always an acute angle. But when we start seeing it in terms of this unit circle, notice that angle can actually be obtuse. That angle can get big, and our triangle can end up being formed on this side, which also ends up having some interesting implications for it. Because you'll notice, like if I'm looking at how far I'm going over to the left, that's a negative number then for our coordinate, because that actually tells me the x-coordinate of that point. The origin is here at 0, 0. So left of that will be negative, and down from that will be negative numbers as well. Up, of course, positive, right, still positive. And so just a couple things, just to be sure we're clear on that. Yes, sine and cosine can be both positive and negative as a result. You've seen some questions pop up so far where sometimes that happens. This is why. But also, when we talk about the angle measure, we're still just kind of measuring how far around the circle we're going in this counterclockwise direction from 0, the same way that we measured our angles before today. All right, and so we're going to be using that information today to be able to build a picture of the graph of cosine. And so that's what we're going to be doing here. And our bulk of our work today is graphing y equals cosine of x. So, above your first graphing grid on that sheet of graphs that I gave you, write down that equation, y equals cosine of x. And normally we just kind of make a table of values. And I'm like, okay, what would cosine of 0 be? And we plot that point. Well, do you know off the top of your head what cosine of 0 equals? No. So that means we'd have to break out our calculator to figure that out. And if you do so, you'd end up finding that cosine of 0 degrees equals 1. So there's a point. We can go ahead and plot that. So plot that point, please, on your grid. 0, 1. But then normally we would then go and say, okay, now what if I plug 1 in for x? And then I go to 2, and then I go to 3. But that's going to be a little bit messy. You'll notice my x scale here is labeled with a 90 degrees right there. 1 is this tiny little number that's basically at 0 here. We don't want to have to mess with that. We don't want to have to plot 360 different points here. So what we're going to do is we're going to focus on certain critical points. And those critical points are actually the ones that are labeled here. So the next one we're going to go to is 90 degrees. And so then I could break out my calculator once again, and I could do cosine of 90 degrees. If you did that, you should find that cosine of 90 equals 0. So then there's a point we can plot. We can plot the point at 90, 0. Plot that there. Okay, we're going to continue the same way. So next up is 180. So we do cosine of 180. When you do cosine of 180 degrees, you should get an answer here of negative 1. And so we plot a point there at 180, so over 180, down 1. Next up from there, you can see we're going to be going to 270. Cosine of 270 equals 0. So plot that point, 270, 0. And then we go out to 360. So we do cosine of 360, which equals 1. So we end up back at 1 there. Now, those are just the really nice, pretty ones. And I jumped to those because I knew that they would be the nice, pretty ones. Could you make the graph using other ones? Yes. There's actually a whole bunch of other values. This is just a few of them that you could also calculate and plot. But I don't expect you to have to do that for every single one of these. That'd be a pain. And so what we're going to do is we're actually just going to use those few points that we plotted at 0, 90, 180, and so on. But I do want you to notice that if I did find all those other points in there, notice what the shape of my graph is going to end up looking like as we start looking to draw a curve through here. Because as I look at this, notice it is not going in a straight line between 0, 90, and 180. We might think so if we were just looking at those points. But you'll notice that when we calculate some other detail, it's actually starting by going kind of flattening out there. And then as we head down, it flattens out down around 180 as well. When you draw this curve in, it actually is a wave shape. It is, as I like to say oftentimes as a reminder about this idea, it is a wave, not a lightning bolt. So a nice smooth curve, not straight lines. Okay? Now, notice we drew that curve on the right side. We need to also fill in what's going on the left side of my picture here. Now again, I could go through and I could do a whole bunch of calculations all over again. I could actually go through and I could plug negative 90 into my calculator and see what cosine is. I could do cosine of negative 180 and see what that is, and so on and so forth. But I don't want you having to do all of that every single time. And so, we can actually follow the patterns here. So, at 90 degrees, if I follow this pattern that I see here, where do you suppose it's going to go next? Well, based on this, does it seem like it's going to be going up here like that? No, because it's kind of flattening out here. So, is it going just horizontal? No, that wouldn't make sense. That it'd be curved and then all of a sudden just a flat line. And so it must be heading down. Now, one little thing to notice about this, though, is we have points at the top, the middle, and at the bottom of this wave as the main ones that we plotted. Notice, you do not go straight from the top to the bottom. In order to go from top to bottom, you have to pass through the middle. That's why at negative 90, we can know that the point is going to be in the middle again. And then, of course, if I went from top to middle, am I going to be going back to top from there? Does that make sense? No. We would have to be continuing downward. So the next point at negative 180 must be at the bottom. We can follow that same reasoning to see where all the rest of those points should be on the left-hand side. So we're just following a pattern. And that's all we're doing, is following a pattern to get those points. And of course, once you've drawn in those points, then we can go ahead and draw the curve through them as well. So another chance to practice drawing in this wave curve. All right, so having seen this, notice I basically drew this one wave over here, and then when I went to the left, I basically just repeated it, right? This wave actually does continue going on forever in both directions. We could plug in any angle, no matter how big we wanted it to be. We could figure out what cosine of 1,000,000 degrees is, and we could actually find out a value. And I can tell you that that value would be somewhere between negative 1 and 1. Because you notice, our entire wave here exists entirely between negative 1 and 1. And we could just keep doing those. So as you take a look at this and see that this graph does continue on forever, I really want to reinforce that visually. So notice here, if I start zooming out on this graph, I would just see more and more of that wave headed off into forever, where you just see lots and lots of those little waves in there. Now we just graphed this one little part of it, but the entire graph keeps on going. Now, I want to note a couple things about cosine. Now, as we talk about these, for some of you, you might actually want to write these things down into your notes as we go, but realize I'm not leaving them up expecting that everyone's going to be writing them, so I'm not going to leave them up that long, but they might be things that you might want to make a very quick abbreviated note of. One thing to note is that cosine always starts at the top of the wave. In the not too distant future, we're going to learn another type of function that looks a lot like this, that does not start at the top of the wave. So part of how we remember cosine is remembering that it starts at the top of the wave. And if you remember that, then we're able to build the rest of it from there. Now, as you take a look at our wave here, there's actually a few other little pieces going on in the background. The graph has a midline in it. And so that midline is right there at 0 for this graph. It's exactly halfway between the top and the bottom. The distance between the midline and either the top or the bottom of the wave is called the amplitude. And so as we describe these waves, we'll be talking about, okay, where is the midline? So like, that's the center of it. But we'll also be talking about the amplitude. And again, I need you to remember that the amplitude is not the total height of the wave, but rather the distance from the midline to the top or the bottom of the wave. So, new vocabulary, midline and amplitude. One other thing that's worth noting, in our parent function that we just graphed, notice your midline is at y equals 0. So by default, the midline is at 0. Your amplitude of your parent function, in other words, your default amplitude, the distance from that midline to the top or the bottom, is 1. And so if we don't change it, and we will be changing it at times, when it's not changed, those are the numbers you need to know as we go forward. All right, now, in order to make this, notice we basically followed a pattern. Every 90 degrees, we fell into one of these points, the top, the middle, or the bottom. And again, that's every 90 degrees that we plotted those. Now, if you know this pattern, it's going to let you be able to make that graph, because I know that I'm going to put my first point at the top, which was where 0 degrees was. So at 0 degrees, I put it at the top. And then I went to the middle, which is wherever the midline is. And then I go to the bottom, which is wherever that lowest of the 3 lines is. So notice, these 3 descriptions, top, middle, and bottom, all correspond to these 3 lines that you can see drawn dotted on our graph. And yes, they do need to be dotted. We don't draw those in as solid, because then that means something different, and it's going to get you into trouble potentially down the line. Always draw in lines like these that we use as guides as dotted, just like we did with our asymptotes. Now, in case you haven't already made the connection, you've been working with this graph already, haven't you? You've seen this shape of graph come up on those WAMAP assignments recently, but I didn't call it cosine then. Why? Because I didn't want you worrying about like plugging cosine into your calculator and trying to figure out a connection to cosine. I just wanted you to focus on the graph and dealing with this wave and how to work with something that looks like that for a change. And so, all of those wave functions that you've been graphing on WAMAP, you've actually been graphing already cosine. So I already know that you can graph these. Because if you can graph wave, you can graph cosine. And so we're going to use that to graph this equation. So please write this equation above your next graphing grid. Y equals cosine of x plus 2. Now, when you saw this on WAMAP, one of the great tricks that I found with the WAMAP is start by drawing the original function and then just dragging the points up 2. Because, of course, when we have a plus 2 hanging on the end, that's all we're going to do. And so if I drag them all up 2, this is where we end up. But this can be awkward to do trying to go straight to the points on our paper. So when making one of these graphs, step 1, draw the midline as a dotted line. Now, your midline is however far you've moved it up or down. Since this one has been moved up 2, you draw your midline up at 2. So draw your dotted line up at 2 here. Okay, step 2. I want to be able to see the other lines there, the top and the bottom. Now, how far up and down am I going to be going in this case? Well, in order to know how far up or down we go, that gets changed when we multiply cosine by something. Well, am I multiplying by anything here? No. So that means it's not changed. What is the amplitude in my original graph, my parent function? 1. And so the amplitude here is still 1. And so I draw in the dotted lines for the max and min here, the top and the bottom. Up 1 and down 1. So draw those in as well now. So notice I'm drawing a line 1 above the midline and 1 below the midline. All right, so once we've drawn in these 3 dotted lines, now we can go ahead and worry about applying the points. And the nice thing is that these points all go on one of those 3 dotted lines. Every single one of them goes on one of those lines. Now, where does cosine start? On the top, middle, or bottom? And so if cosine starts at the top, then I go ahead and I plot that first point at the top. And then every 90 degrees, we go to the next one, the pattern. So notice, top goes to middle at 90, and then we go to bottom at 180, then middle again at 270, and then top again at 360. And so I'm just following the same pattern of top, middle, top, middle, bottom, middle. You're going to get to know that pattern really well, because once you know that, you can draw the graph of cosine. And we just extend that on the left-hand side, following that same pattern, and we have our cosine graph.